You have your direct reporting, okay, but then you have some other declared and known things that are indirect, like I might report into a project and there's a project manager who's responsible for that. I might have a mentor, but then I can look at things like email and Slack messages and other kinds of communication, look at how information flows in the company, and then understand what's the real org chart. You could just look at, there's lots of AI technologies that'll let you understand what's the topic that people are communicating about, who's receiving the most emails that are questions about a particular topic. And if those emails are only going to one person, then you've actually got a single point of failure inside of your organization.
I'm Ryan Heath, and welcome to the AI Leadership Lab, where I interview C-suite leaders about their AI journeys. We cover what's working, where they're getting stuck, how they pivot, and the lessons they take from the losses.
Joining us now on AI Leadership Lab is Philip Rathle, who is Chief Technology Officer at Neo4J, who have been AI pioneers. And if you don't know about what they do, we're going to hear a lot more about the technical details and the strategy in the course of this discussion. Welcome, Philip.
Thanks, Ryan. Pleased to be with you.
Philip, let's start with your own AI journey, the shift from consulting into the graph database business. And maybe if you can share us one or two pivot moments where you realized that the relationships between data points were the key in the next era of data infrastructure.
I started my career in consulting and very quickly landed into data. I ended up getting into data modeling somehow pretty early on. So early on, I became convinced of a couple of things. That one is data is essentially a mirror or representation of a business. And so the better your data is, the better handle you have on what's going on with your business, in starting with even keeping track of customers. So early on, actually co-founded a startup around Customer 360 after having built United Airlines' first passenger 360 system. And something we discovered that is many of the companies that we're talking to actually had a problem with corporate hierarchy. Like anyone who's worked in data and understands how companies work, is you have all these different hierarchies, like hierarchies of different business units, hierarchies of departments, hierarchies of like salesperson reporting into departments and owning different territories. And for every company, it's a different hierarchy of like locations and what locations report into which ones, and then people reporting into all that. And then fast forward to, getting into graphs. I remember in the early 2010s, there was a lot of movement around alternate ways to store data. And the big problem people were trying to solve on the operational side of the house. So it's things like, if I'm enabling e-commerce, I need to be able to retrieve the contents of a shopping cart based on like some identifier related to a person. And as it turns out, like it's a session related to that person and a cookie. But basically, it's just like a straight lookup, and doing that straight lookup millions of times per second. And there's no connections in there. And I remember going to my first NoSQL meetup at Netflix, who was a big user of this technology called Cassandra, which effectively is like store and retrieve data without any concept in the data model of connecting things up. And I thought to myself, someone is going to start building with this, and they're going to realize they need to connect up the data, and then they're going to build a whole layer on top of it to do something that you should be doing in the database to begin with, which led me to, by the time I met with Neo4J's co-founders back in, as they were raising for their Series A, I saw them going all in on relationships, which I'd always seen as being more valuable.
And famously, Facebook, before it was Meta, was pioneering the social graph. And the example you gave with the airlines is super fascinating, because you think about how expensive airline tickets used to be. They couldn't fill the planes, they couldn't treat their customers correctly. And now, with much better data, they know exactly who you are. Those planes are nearly full every time. I'm not sure the tickets are always cheaper, but in theory, they could be as a result. So
this is true. And then the other pioneer in connected data and graphs is Google. I think about them as like a $1 trillion graph company, because what differentiated them in the early days, when there were 30 plus other search engines out there, and you remember them, like the Lycos and Excite and Webcrawler and all these things. What was different about Google is one graph algorithm. Is they said, I'm going to rank the pages based on not like the number of times that someone's repeated something in 1 point white over white font and just, to take the words at face value. But I'm going to look at the structure of how the web pages are connected and give higher rank to pages that are more referenced by other pages. And And then actually they do that recursively to avoid gamification, so that pages with higher referencing pages with that have more referencing pages get higher weight than ones that don't. And then Google disrupted itself 12 years later with a knowledge graph, which is taking information about what those things are on the pages and what those concepts are.
And maybe if we can pause on the knowledge graph point for a second, I think that is a term that a lot of people listening have literally heard before, but it's probably still abstract for a lot of people listening to this podcast. How do you explain it to people outside of tech in your life, like at Thanksgiving or if you're headed home for the holidays?
Really, the key word in there is knowledge. And so what is knowledge? It means it's distinct from having all the facts in the universe about something. It's like, what matters? What are the things that matter? And then inside of that, what are the relationships that matter? And why are the relationships important is for context and causality. If I want to understand someone like really deeply, I can get all the facts in the world about them, and that'll tell me some amount, like that's useful. But I can do a better job of understanding who they are and even predicting their behavior if I understand how they engage with the people around them. If you only have facts about people who are friends of friends of friends, so they're not only people that you don't know, they're people that your friends don't even know. But if you understand those people and how they behave, that ends up being a better predictor of someone's behavior than having all the facts in the universe about that person, which is pretty mind-blowing. But that's true of everything.
We're not that unique. Everyone thinks they're unique, but actually we're pretty much like other people at the end of the day.
And like, to what degree are these decisions that we think we're making entirely of our volition being made because we're being influenced directly and indirectly by people around us? Like who we hang out with has a profound impact on who we are, because we just, we're social creatures. But the whole world is interconnected. Computer networks are interconnected in exactly the same way. One thing goes down and everything else goes haywire. The same thing with ecology, biology, supply chain. We learned about that, getting a ship stuck sideways in the Suez Canal. Like, the whole world is interconnected. And so if you try to just deal with data as facts, then you actually miss out on understanding things in their context and deeper cause and effect. So that's what a knowledge graph is. And that enables all kinds of better, deeper understanding, and also narrows the distance between the business person and the technology person and the language they're using. And that has side effects of increasing velocity and then increasing understanding, of course.
Yep. That's going to be a big point for a lot of people listening, is that connection between the tech and the business strategy sides. And it feels like I've got a metaphor for you. It's actually like the true org chart rather than the one you get told is the org chart, because that never really represents the power relationships in an organization.
Okay, so there's an amazing rabbit hole here, which is you have your direct reporting, okay, but then you have some other declared and known things that are indirect, like I might report into a project and there's a project manager who's responsible for that. I might have a mentor. But then deeper than that, that's still the way the organization thinks the world is happening. But then I can look at things like email and Slack messages and other kinds of communication, look at how information flows in the company. And by the way, we have some very large companies that are doing this, and then understand what's the real org chart. Who's receiving the most emails that are questions about a particular topic? And if those emails are only going to one person, then you've actually got a single point of failure inside of your organization. And if that person is unknown, then maybe an opportunity for that information to be used by management in a way to structure things better. Another one is understanding the information flow and communication flow from people inside a company to outside the company. We have a number of companies that will also take the same graph of communication and say, look, if, like, let's say I'm a support person or I'm a salesperson and I'm trying to get in touch with someone at a different company. Well, there's nothing better than a warm personal introduction. Well, who are the other people inside the company that have been in contact with this person? And obviously this stuff is all subject to regulation and privacy and so on, but there's a lot you can do within those boundaries.
Now, there's another big unlock here potentially, which is as AI systems develop, they face trust issues. A lot of people simply don't trust AI because they're not technical people, so there's some level of ignorance there. A lot of the biggest language models we've all been using over the last few years, they're black boxes to a large extent. And so clearly there's been a push from a lot of people to try and make AI more explainable. And it feels like some of this graph-based retrieval, that could play a role in making the AI more explainable and increasing trust. Do you buy into that theory?
Spot on. The systems that are succeeding are the ones where you recognize the model's strengths and limitations, and then you bring in other technologies to complement those strengths and limitations so that you can best leverage the strengths and then overcome the limitations. Because if you're stuck in a game of, I'm going to just hope that models overcome these limitations of they hallucinate, meaning they sometimes give the wrong answer, but they don't tell you when. They're a black box. Also, they only know about the information they've been trained on up to that point in time. And once they've been fed information, they have no discernment about what's appropriate information to be used for what purpose inside of, at what time by what person. And those are all fatal flaws. And like any one of them is a fatal flaw for most enterprise use cases, anytime the stakes are moderately high. And so you have to complement them. Otherwise, it's trying to squeeze water out of a rock. The models just aren't there. I potentially believe they're not going to get there. You need other technologies alongside. So in the graph world, what we're seeing, in the AI world, what we're seeing where LLMs are, oftentimes you'll just try to use one or more LLMs as part of solving a problem and then very quickly realize it doesn't have my enterprise data. It's a black box. It hallucinates. So then what you do is you bring in a knowledge graph, and a knowledge graph serves as a knowledge layer where I have the information that's specific to a company that's laid out in a way that is understandable and is actually more understandable to the business as well, because it's shaped like a graph, which is like a network, which is more the way the real world shows up. But where you can also run certain kinds of computation and get exact results. So let me give you an example. With supply chain, you know exactly what your supply chain is, and you can run calculations, and it's, quote, just math, but it's math maybe going 20 levels up with tens of thousands of components. And a model will 100% of the time hallucinate the result if you try to get it to do this math 20 levels deep across tens of thousands of components. It's just not the right technology for that. Whereas graphs...
Well, can I stop you there for 1 second? Because isn't the point, it's a language model. So if you are using a general language model that isn't trained on the specific math or data sets of your organization, well, it can make something sound pretty, which is that's what a hallucination is, a pretty sounding answer, because it's doing the language task correctly, but it doesn't have the data input to reason correctly around your data. So it's kind of, I don't want to say it's obvious, but after 3 years of this now, it's obvious to me that if you're just using an off-the-shelf model that's not trained on your own data, of course you're going to get these problems.
Of course you are. This is where we come back to, there are many different kinds of AI. Generative AI is one, and then language models are like, an important part of that. But then you've got, graph AI. If I can get some kind of computation that mathematically will tell me the shape of the data around a particular thing and the shape of data around another thing, which, by the way, these things exist. They're called graph neural networks, which is like a form of a graph vector. You can then say, for this new thing coming in, does its behavior have the topology? Does it have the shape of something that is known to be fraudulent, or of something that is known to be a high-value customer, or of something else? And so there are all these different ways to use math and to use AI that are distinct from just language models. If I want exact answers to complex computations or multi-level stuff through a network, there's a very mature set of technologies. In fact, it's one of the few parts of the AI stack that has an ISO standard, like that's been standardized for querying graphs and graph databases, which is a lot of what people at the leading edge of AI are discovering, and what distinguishes that. If you believe the MIT numbers, the 5% or maybe 10% by now of projects that are succeeding versus the ones that are failing, is understanding what the right sets of technologies are to use, and that you need a system of knowledge in addition to a system of language computation.
And is that sort of that ISO standard the key thing for someone out there in their organization? They're the technology buyer, and they've got to figure out, am I buying people to build this in-house? Am I going out to a third-party supplier? There's the ISO standard. Is there something else that people need to look for as they assess whether they're going to build or buy on this graph side of the work?
So on the graph side, what I would not recommend is trying to build a database management system from scratch, just because that takes many, many years, and your time is better spent buying a database off the shelf so that you can focus those productivity cycles on being more competitive and doing what you do better as a company, in the same way that no one's going to go build their own networking infrastructure, their own computer monitors, and so on. And then inside of that, what technology do you use for your knowledge graph? I like getting to the answer by looking at what are the needs of an AI system of knowledge? What do I need from my knowledge system? One need is I need to be able to read and write data transactionally. So I need a system that's going to be like a proper database that is not just analytics, that is also able to respond in real time, because I want my application to power it. So it might seem like an obvious thing, but if one doesn't establish this the requirement ahead of time, you might just get an analytics system and realize that it's not designed for having tens of thousands of users all asking questions and expecting an answer fast. Another one is you want to be able to have explicit context that is understandable. So that points to data shape like a network. You want to be able to bring together data silos. So again, that points to connections and saying all these different identities I have across systems, let's reconcile them in some ways. And one that I feel is very important is you need to be able to add new kinds of data without having to do major surgery on your system and schema. You need to be able to add and subtract easily. So schema flexibility ends up being an important one.
Yeah. Now, when generative AI hit the market, the big debate for that first year or 18 months was sort of the size of the model and what the next update to the model was going to be. And what I've noticed over the last year is the debate has really shifted away from that and much more into the infrastructure side of things. So what is the data demand? How are we going to actually power all of these different AI products and systems? How do you think sort of the growth of this use of graphs is going to affect AI infrastructure? Is it going to affect energy consumption? Is it going to make the use of the existing LLMs much more efficient because we're plugging better things together in one stack? How is the infrastructure side going to shift?
Yeah. People usually start with a large model to see what's possible, and because large models are more capable. But what I'm seeing is the systems, as they get closer to production, for economics and also for just like latency, if you can run a smaller model faster on the same infrastructure and more cheaply because it has less stuff to grind through. And so you basically want it to have less of the stuff you don't need and only the stuff you need. And so actually things have moved in the opposite direction of how can I surgically pull out the data that is most relevant to a particular question, put that into the prompt of the smallest possible model so that I can get the fastest and the best result possible. And so it's using models for less, or let's say maybe smartly, and not for everything. And there have been a number of studies, and I see this time and again with customers, where the amount of data that you need to put into the context window to get not only an equal but a better result is oftentimes 2/3 less if I'm doing graph rag than if I'm using other techniques. And graph rag is just a fancy term for I'm going to query a knowledge graph and take the results and feed it to a model as context. So I do see energy savings, latency, in addition to better answers.
Okay, well, that maybe brings me to my last question, really, which is about where you see the most potential for that kind of graph rag sort of systems over the next few years. The one that jumped out at me was healthcare, because if you're in the operating room or something like that, you don't want latency. You want absolute best and quickest answers possible.
I see it as very horizontal. Healthcare has, in my experience, been slower to adopt new information technology, or let's say their technology investments have been much more focused on maybe the clinical side and new pharma compounds and so on. But there's a huge information technology opportunity. And I have seen cases where and we've even got like some demos out there of making personalized recommendations based on someone's history, baking for sure, both on the engaging better with customers, on the positive side, of course, risk prevention as well, and anti-money laundering, and hopefully shutting down all of the new kinds of scams that are appearing with Gen AI. Like all of a sudden, all the phishing emails are getting a lot better. Like you used to be able to spot the typos, and now it's...
I fell for one last month, and I was like, nothing bad happened. It was a fake one from my company.
My company does that too, and I occasionally fall for them too. It's hard. We need to be very vigilant. So having extra technologies that can have your back. Life sciences and pharma, nearly every pharma company actually does use Neo4J to accelerate the drug discovery life cycle by about a year. But there's greater opportunity there by pulling data, all the research that's been done public and private, having it in a knowledge graph. I've seen this in many pharma companies where you can then start to ask any kind of question and just get way better answers and accelerate different steps. So I think it's going to have a profound impact for medicine. But then if I look outside of business impact, there's one human impact that I care a lot about and I'm very optimistic about. I feel like, our agency is important, and then understanding where the answers come from is important. And we have technology that can do this. And we have checks and balances inside of existing companies and existing regulations that regulate many outcomes that are already regulated, where it's not good enough to just have something occasionally be wrong and not know why. So where I'm most optimistic from, let's say, a human perspective, is that this provides a technology component inside of the AI stack where we hold the thing accountable to exact 100% accurate results in the cases where that's needed and where we require it, and where there's some explainability and we can go back and check the answer and know when it's right, when it's wrong. And if there's a bad answer, you can just go back to the data, see why it was bad, fix the data, and then you're good.
If we could get to that point, we will see a true explosion of AI. There'll be no reason not to trust it if we can make that happen. Philip Rathle, thank you so much for joining AI Leadership Lab.
It was a pleasure. Thanks, Ryan.
Thanks for listening. 2 things before you go. First, if you'd like to appear on the show or know someone I should have on, you can find me through ryanheathconsulting.com. Finally, please tell a friend or colleague about AI Leadership Lab. Even better, leave a short 5-star rating or review on whatever platform you found this podcast. It'll help us reach more of the people who'd enjoy these tips and tricks. Thanks, and talk soon.